Can you confirm we'll be able to see the network again?
Yes.
Okay. What we validating earlier, can you mute the music on the other side? Sorry, oh, accessing the music, can you please mute it? So we after we running the load flow, we can see the lines are loaded 35%, 16%, and 43%. But from the load flow results, we can able to see the current for the bus walk because we have to protect the system. The load flow is fine. You can see the load flow is running and compiled. But however, the generator here is kind of bit of overloading. Like example, this one we put 218, but here is 200 181. So it means it's bit of slightly overloading. Let me see where the megawatt we putting it for the slack generator. Mm, So now the next step is we need to do the protection. To do the protection, we need to look the current that is flowing on your line, which I'm looking at is a 3.13 kiloamps on substation 1. If you're looking at the report here, line 13 is the substation 2, but this is substation 1. Substation 1. Okay, there is a substation 1. Substation 1, if you look, the load is 7.48 kiloamps, and the line 1 2 is 3.13, and line 2 3 is 4.48. It means here this substation, what is the current? The load current is 7.48, So we have to calculate your protection setting and try to install the relay on this location so that we can able to protect the system. Um, in the guide that is explained here already, so going back here, so basically we done all these settings here and we did the load flow and we busy analyzing the load flow results. Just one second quickly. Let me check the line impedance quickly. If it is right, line 1 2, it is 10.26 and then 1.0.125, 0.25. Let me quickly open this line 1 2. And 25 kV, 10.26, that's right. And then you look at this one, 0.125 and 0.25. So this data is right. And then it's fine. And then the second line is this one, line 13, line 13 data. By looking at here, line 13, especially the resistance and reactance, which we calculated 0.6 and 1.88. So this is also exactly looks right. And then line 23, line 23, 0.078, 1.16, and 10.26, and 33. So everything is looks right. Load is industrial load. Okay. Oh, I see. The load is data is wrong. That's what I'm looking at. Why the current is going less. So the load is 400 megawatt and 250 megawatt. So now you can see the results exactly matching with the report what we're presenting. I think the mistake here is the load I put 200 megawatt instead of 400 megawatt. So if you're looking at a report here, did I close it? So this is a log for results. So let me compare this one with this one. You can see it exactly. This line is 46.1 percentage, and then you can see this line is 46.1, and this is 1.6, and this is 63.2 percentage. So everything is right, and then I compile the row flow results. So before I compile, I just clear all these things. Compile the load flow results, complete system report generated here. Let me look at these results with the report that I produced here. So if you're looking at these results here, your cubicle 1, you can see bus 1, that means bus 1 is here. I think this is bus 2. If you look at bus 2 here, 11.21, and A is 11.21. And then 4.73 kiloamps and 6.48 is exactly the same what you're looking at bus 1. That is bus 2. And then if I scroll down here, this is bus 1. For bus 1 currents, this one you can see here, the bus 1 is top here, 5.71, but 72, 4.73, and zero point 0.9 the currents that flowing on the different devices, because this line 1, 2 is 4.73, line 1, 3 is 0.99, and the synchronous machine is 5.72. And then the last bus is it your bus 2, and bus 2 is here 11.21, 4.73, and 6.48. So the load flow result that I produced in the manual report and the simulation that actually we did is the same. Now the next step, we have to do the protection calculation. For protection calculation, I already specified in the manual, just need to highlight you. Okay, before we go into that, I just also compared in the manual your load flow results with the MATLAB and then the DigSilent. So this part here, this is your load flow results from the MATLAB and DigSilent, but you can see the slack bus, the voltage is 1.05, MATLAB and DigSilent is the same, and the phase angle is the same. But whereas your PQ bus in the DigSilent is produced 0.97, in MATLAB is 4 decimals, but it doesn't change. But let me check here also for the voltage profile in the DigSilent. Yeah, so this is what we're looking at. If you look at your bus 1, which is a low, you can see a 1.05 angle of 0 degree. You can see the same thing is happening in MATLAB. MATLAB is also the same. And when bus 2 is a PQ bus, so bus 2 is here in the top. You can see 0.97 and the angle of minus 2.72. In DigSile and my report, I put in 0.270, but here the result is 272, but appropriately, which is equivalent to your MATLAB, because MATLAB is 2711. And then the PV bus, which is a bus 3 is this one. You can see 1.04, the angle of minus zero point 0.5 in DigSilent, and MATLAB is minus 0.502. So apparently, if you're looking at this first column for the voltage and the phase angle for all the three buses, your MATLAB and the DigSilent will appropriately the same and is producing the same value. And then from the real and reactive power from the MATLAB results and the DigSilent results, if you look at your slack bus is producing in DigSilent 218 megawatt. Let me look at those things. Okay, this is the detailed results. In the detailed result, this is bus 2. Let me looking for bus 1. This is bus 1. But if you're looking at bus 1, you can see here this one, if you see 218.43, but you can see the DigSilent, yeah, I put in the report 218.42, and MATLAB is 218.41. So you can see approximately is producing the same. And then that is your real power from generator. For bus 1, bus 1 is a slack bus generator is pushing. And then the reactive power from the generator is 140.77. You can see the next item here in the same results what I'm presenting here. The next item here you see a 1.14077. This is what this one here, 147. Are you with me? And then we go into bus 3, which is a PV bus. So bus 3 is this one, and in the report here, if we're looking at here, so bus 3 is the bus 3 is a low is the your PV generator, which is producing 200 megawatt and reactive power of 146. So bus 3, if you look at here, the real power is 200 here, and then the reactive power is producing 146.46. Where is this see? Can you see here? This is 146.46, but the DigSilent I put 40, but here the actual one is producing 46, but it's very pretty much close. So by comparing the DigSilent and MATLAB simulation results in your report that is provided is pretty much the same result that is providing, even though it's a different platform that we're using. All right, all the screenshot I provided and the MATLAB result, this is already available in your practical number 4, but I captured this screenshot here again to compare the comparative purpose of the results which is produced in the MATLAB. And the animation load flow and stuff I spoke. And then the other item, we're going to do it the 3-phase short circuit. For the 3-phase short circuit, the protection setting, okay, the 3-phase short circuit, let me do it and calculate the thing and compare with the report. So I'm going to apply a 3-phase short circuit, right click, calculate 3-phase short circuit, and we're using a minimum short circuit current, and we execute these things. And when I'm looking at here, the 3-phase short circuit is producing 19.7 here, and here is producing something 8.256 kiloamps. And in the down, if I go, I can able to see the short circuit report. So I can see it here. It means the line 1, 2. You can see the line 1 2 here. This is 8.25. You can see the line 1 to 8.26 kiloamps. But the bus, if you look at this bus, it is 19.7. That is 19.97 something. If you look at 19.79, but here approximately is taken 19.80. And then line 1 2 3, so it means this line here, this is line 1 3, which is producing 11.54, and here the result is producing 11.44. So from the short circuit we see the line current that is going from line 1 2 to bus 2, which is approximately 8.256. It means this current. Are you with me? So the line current, that if I apply a fault at bus 2, the current that is flowing from the line to this bus is coming 8.26. That's the fault current. And in your report, I already produced this fault current here. I applied, and you can see here the fault current exactly what we're discussing in the previous case. You can see at bus 2, you can see the fault currents here. Which current we're looking at? 10.29 at bus 2. Okay, quickly review it. IK double dash, but it has little bit less current. We have some internal resistances that is acting, internal impedances. Let me check on this bus. Oh, I see, it's a different method you use. So we have to use IC6099 method as explained in the guide. Then we can able to regenerate the report. Is it IC 609 Yeah. Now we're getting the fault current, which is 827.9, 10.29, and 17.50. Mm, which is a little bit higher than the one. Why there is a deviation? We can check minimum short circuit 26. This option is right. So it means we're getting the fault current of 8.25 kiloamps here. And then if I run a normal load flow, we're getting a current of something 4.73. So it means your protection function mustn't operate for the normal load current, which is 4.73. But sometimes if the line is overloading, but there is no fault on the system. So from this, what we understanding is the normal load current is 4.73 kiloamps. And if there is a short circuit happening, this current goes to twice, which is something getting 8 point something. If I apply again the short circuit here, three-phase short circuit, so we're getting something close to 8.256. Okay, so the normal current is point something, and the load current, the short circuit current is 8.25. So your protection setting, when you're looking at the pickup setting, which mustn't be tripped for the normal current, and also which mustn't be tripped for the overloading of the line. And the overloading, usually the industry practice is it must be overloaded anything above 120 percentage to 150 percentage. So if you're overloading anything between 120 to 150 percentage, we also need to make sure your protection function is not tripping. And but make sure that overloading happening only for few duration, not continuously. So our protection setting must be lies behind the fault current, less than the fault current, that is 8 kiloamps, and also your less than the fault current, and also must be higher than the, let's say, 150 percentage of the load current. That's why in the manual I just produce these things here for protection calculation. Become all those things later. So you can see the fault current calculations. I put it from the protection setting. Is the 4.73 is a normal load current, okay, at line 1, 2. And then for the fault current, so that's why they specify the fault current. So it means your pickup fault current because it's getting 8 kiloamps for the fault. So what I'm trying to say is this 10.2 amps, whatever thing that you're getting, and if you multiplying 150 percentage of the load current, it's supposed to give you something 7.09, but the fault current is 8 kiloamps. So we must be setting our protection setting, which must be lies within this value above 150 percentage load current and below the fault current value 8 kiloamps. That's why the protection setting, the pickup current for this one is considered as 8 kiloamps in this case. So it means it's only tripping for the fault condition, not for the overloaded condition. I don't know if this is clear for you, the protection setting. Now I can do the protection setting in the DigSilent software. So the concept here is for the protection setting, we're selecting 8 kiloamps as a secondary current, and if the safety ratio is 1000 is to 1, yeah, 8 kiloamps divided by 1000 will become 8 amps per 8 amps secondary current. So that's why we're selecting 8 amps secondary current. This is basically your fault current, three-phase fault current at bus 2, which is injecting 8 amps into the line 1, 2, because your relay is going to sitting at the end of the line 1, 2. Okay, to introduce the relay and stuff, there are many ways you can do it. The easiest way you can do it by placing your relays in the network. Example, the protection devices here. This is your CT and this is your protection relay. So the protection relay, you can place it here in this cubicle. So the relay is in this cubicle. If I go and open here, you can see the cubicle. Edit devices. Doesn't look like. Let me try again. The relay and the city devices must be connected there. We can do this in here. Okay. And then the city comes here. So now we done our protection relays. Example, this is your relay and your cities is also connected there. So you can see this relay, your current transformer, that is the incoming current is going and the relay is there. So if I open up this cubicles, you might able to see it here, because if you go here you can able to see the relay and the locations. You see it's bus 2 and then it's connecting to the substation cubicle 4 IOS 4. So you can do it this way, or otherwise you can right click this cubicle. This is a breaker of the bus 2 incoming. You can right click and you go to new devices and you can able to insert the relay model from the library as well. Okay, there are two ways you can do it. The best way is you can take your relay from the graphical diagram tool. There is a relay in the protection library. You can take the relay, you place it there, and then you can take your CTs and connect the CTs from where you want to measure the current to the relay. Okay, so that is done. Now we need to configure the CTs and the relay. For first the CTs, for is a current transformer 1 amps to 1 amps, but I want to create a new project transformer care, but here we need to specify 1000 is to 1. So you can see 1000 is to 1. This is CT. And then you can already, when you define inside, when you go and open and check, you can see the CT 1000 is to 1. And for the relay, you need to select the project. Is not a new project, it's an existing project which is supposed to be in a relay library. It directly taken to the DigSilent database. In the DigSilent database, there is a protection devices library. Under the protection devices library, you can see the relays from different vendors. So in this exercise, we're going to use a SCL vendor and we're going to use a feeder protection relay 751, and there are two relays 751 secondary 1 amps and secondary with 5 amps, but in this specific example we're going to use secondary with 1 amps. So when you put these things, because this relay model is developed by cooperation with the SEL and the DigSilent. So the library, it means what you're looking at here, this is a physical library. You can able to, just one second, you will able to see this all the physical relay. So what happened is the SEL vendor and the DigSilent in a cooperation, they able to develop the software version of those relays, and those relays already pre-installed in the DigSilent software. So when you install the software, there is a library under the DigSilent library protection devices goes, and all the relay that is already in the DigSilent supported version, they will be pre-installed. So we can able to use the relay and test the protection functionality. This is a cooperation with the vendor and the DigSilent. They did a soft version of the relay which we can able to perform the protection function. Example, this type of relays, we have a physical relays in the lab. In one of the research lab in Center for Substation Automation, I think it's in the same flow way you're doing your Goldfield labs. We have a lot of ACL relays from 751, and there's also another protection relay in block A in the new building. There is a protection lab is also available, and we also have some few SCL relays in that lab as well. But those are the physical relay, but this one is a software version of the same relay that is available in the DigSilent. Just to please take note. So already the relay library is there. Now what I want to do, I want to configure the CTs and PTs. CTs already I done is 1000 is to 1 amps, and there is a core transformer for the ground fault, and this ratio also the same, so 1000 is to 1. And in this case is a overcurrent function, so I don't need to measure the voltage. It is a secondary voltage potential transformer, so I leave it as it is. Then I will go and configure only 50p1p. In this case, all other elements I just need to put out of service. I can quickly do that functions because we're only looking at 50p1 element. So all other elements I'm going to put it out of service. You can see there's a tick mark there. It means it look like it is out of service. So only we're going to configure the 50p1, and this 50p1 I need to specify is 8 amps and 0. Why we specifying 8 amps? You can see 8 amps secondary, which is equal to 8000 amp primary, because this is a fault current. So if there is a three-phase fault happening on the network and the line current comes, the three-phase fault current comes to 8 amps. So we want to protect them by the setting of the fault current value, which is a minimum fault current value 8 amps. So these all other elements must be out of service. Okay, all the elements we done. So only 50p1 is active and all elements are not active. So I put them, all of them are out of service. All right, click OK. And then we can also able to draw the relay characteristics curve. So if there is a relay, we can add the time over current characteristics curve, and from there you can see your time over characteristics curve is shown in the picture. So it means it's showing your time over current here. Now we can able to apply. If I click this one, you can see this element is 50p1. So we can also put the labels if you want. You can see the iset and stuff is coming. So 8000 on primary. Okay. Now we can apply the fault to see if the system is tripping. Um, this is the 8 clamps, and you can see from the results for 8 clamp primary current you're applying, and then it tripping in 0.21 seconds. You'll be able to see it. So if I apply the fault on the bus 2, which is producing about the line current which is passing through 8.26, but the pickup current that is setting up is 8 clamps. So whenever it's received above than 8 clamps, that relay will be able to issue the trip signal with the default time delay of 0.2 seconds. That's what we're seeing on that graph. Whenever you want to put the characteristics curve, you select the relay and right click and show your time over current curve. So then it will be able to show you the plot like this. Basically, that's it for this second section of the lab. Any questions? If you look at your manual here, so we applied the instrument transformers, and we can also able to see your protection settings by clicking on this window here, which is arc flux and protection. And then if you click on this, you select instrument over current settings, and then it will able to produce you what is your transformer ratio. You can see 1000 is to 1, and you can also see your element that is active, which is 50p1, and the pickup setting is 8000 primary and 8 amp secondary, and the time delay is 0 and definite time. So we can also able to view your protection setting from here as well. You click this thing, then you go to the next icon, output for the protection setting, then you can able to view the protection icons. So this one basically verifying the protection setting. And then the other concept here is sometimes if you want to look at the data manager, you can go to data manager, and in the right side of the data manager is the relay library. But here this is my username. So is my library. Under the library I have a lot of network, but this is a network that we looking at. And in this network, if you click on your network data, and then you can able to see your network parameters and stuff. Just want to quickly show you study cases. Just one second. I don't know what you're asking questions. I want to show you something quickly here. That's a library model. This is a network model. The network data. Yeah, this is what I'm looking at. So example, if you go to your username in the master library, that's my name, and I came to the network model that you model 3-bus power system, and under the network model and network data, you come to the project file name. The project grid name is 3-bus system. If you click on the 3-bus system, you can see the station 1, 2. This is a bus 1, bus 2, bus 3, and this is a line 1, 2, line 1, 3, and line 2, 3, and the load and the synchronous machine and stuff. So we can see the details of the network as well in the data manager. And in the data manager window also, you see the relay library. If for SEL relays, you need to go to the protection devices. From the protection devices, go to the relay library, and from the relay library, choose the vendor. For example, we are choosing the SELs, and then if you go to SELs here, you should be able to see a different SEL series relays. But in this case, example, we're choosing a 751, and there is a two option. Choose between 751 amps and 751 5 amps relay. I think I covered pretty much everything on the manual. Yeah, I covered everything on the manual. Mm, any questions? The recording will automatically upload, I will show you now. So it's not me, I'm doing. We can have SEL. When you install the software, the relay library will be there default. But as I mentioning, if you install previous version of the software, you may not have a relay library. But if it is a latest version, the latest version is 2022 in my computer, or even 2023. There, whenever you install the software, the relay library will comes under the, because there is a DigSilent library, and then the protection devices. Under the protection devices, the vendor name is SEL, and among the vendor relay, you can see 741. So it is default. When you install the software, it is installed already. So it's not like something we need to have a separate installation file. And for the softwares, I think the software is available in the lab in Goldfields Lab 1 and Lab 2. You have to use the lab when the lab is available to use the software. So the lab, the DigSilent software is installed in both labs. In Goldfield 205 and 228, I think the both labs that you use, left side and right side, both labs are installed with the software. And only that Goldfield Labs was installed with the DigSilent software, not other labs.